When you hear people talking about Code Interpreter revolutionizing how data science is taught and how data scientists work, it's because Code Interpreter works really well with structured data. So I talked about how structured data, if you have it, is much easier to work with in Code Interpreter, and I'm going to show you that. And working with structured data is one of the first places you should start. If you've got structured data, just go and use whatever data you've got. Of course, make sure that it's okay to work with that data within the privacy and other guidelines you have. But if you've got sample data where you've got something that's representative of the columns and the types of data that you work with, you can go and use that instead. So you can go and use dummy data to help you get a sense of how all this works. Now, let's take a look at an example with Vanderbilt data. So in a separate conversation, I took Vanderbilt's annual report. I extracted a lot of key metrics out of that report using Code Interpreter, and I saved it as a CSV file. Now this is helpful because now I can go and reuse this CSV file and start from the structured data over and over. So here's the first sort of interaction pattern that I'm going to encourage you to use, this conversational pattern when you're working with structured data. Please read and explain the structure of the data in this document. Or please read and explain the structure of the data. I'm going to do two things. One, I'm telling it to read it, go look at it, but I also want it to explain it. Now, why do I do both of these things at once when I'm working with structured data? Well, what I want to do is I want to be comfortable that when it loads that data, one, it's loading the right data set, and two, that the structure that it perceives in the data set is the same structure that I perceive in the data set. Part of what I'm trying to do is make sure that Code Interpreter and me are on the same page. Are we looking at the same data? Does it have the same structure that we expect? Is Code Interpreter able to parse it correctly and get the structure out of it? And this is going to help us answer that question. So first pattern, read and explain the structure. Now it goes through and it says here's the structure of this. It reports on various metrics for Vanderbilt University over the years. The metric, this column describes the metric that the data in the row is about. For example, undergraduate, graduate, and professional total fall enrollment. That is correct. It then goes through and describes the different columns. They're for our different academic years. And then it goes and lists a bunch of other things that are in here. Count of undergraduate students, yield, masters and PhDs, masters and MDs. It has other doctoral. Now, I'm going to come back to this in a minute. It didn't go through the whole data set. It took a part of it and explained it to me. Now, I'm going to start by just taking this data and pulling out of it and displaying something. And this is always a good place to start. A simple pattern is go and have it read and explain it to you, and then have it go pull some selection of data out and display it in a table. Really simple task, really simple pattern that you can apply, but it can help you make sure that you're going to be able to pull out the right things that you want and make sure that when they come out, they're coming out in the format that you're expecting, that they are being, pulled out of the structure correctly. I want to check and really know that we are on the same page in terms of structure and format and these types of things. That when we begin our conversation, we want to make sure that we are talking about the same data, that we're using the same structure in our heads. In my head, I say R, but it's Code Interpreter that it has its same understanding of structure that I do because we're having a conversation. We want to make sure that when we're talking about things, we're using the same terms and we don't end up creating a visualization that looks correct, but is based on fundamental differences in our understanding of the structure. Now, one way I can help deal with that is I say create a table showing graduate and undergraduate enrollment by year with separate rows for each. So I'm being specific about what I want to see and how I want it laid out. And now I see it going and showing graduate and undergraduate enrollment over the years. So we have 2017 to 2021. Now that I've seen it, it can extract it and it's in the format that I expect, I'm going to say visualize each of these as separate series. So now this is a simple pattern you can apply. Go and you've got some data and now say visualize and explain the constraints for the visualization. So the constraints I have are that I want each of these two things, graduate and undergraduate enrollment, to be a separate series. Now notice a couple things. I'm expecting it to infer from the conversation what each of these is. And you don't always want to be that loose and trusting, because sometimes it's not clear from the conversation which each of these refers to. So it probably would have been better in this situation if I'd explicitly said visualize graduate and undergraduate enrollment over time as separate series. That would have been the better way of stating this. Now, I got kind of lazy and sloppy, and I'm just letting it infer from the conversation, and there could be risk there that it misinterprets. Now it shows me the visualization. Now, I didn't give it constraints on colors, sizes of lines, the scales, like any other things about the axes or any of that stuff. And what you want to think about is it's always trying to get to something that works. It's kind of give you a solution, a visualization that works. If you have additional constraints, if you want certain colors, if you want certain series, these types of things, you want to express that in your request. So always be thinking about, am I giving it enough constraints that if it generates something that works, it'll meet my needs? So have I told it enough about what I want? The constraints on the visualization are going to be how you express what you want, and it's going to try to fill in all the other details to make it work. It's trying to find a solution that'll meet your needs or your constraints. This time I have given it very few constraints. I've just told it what the two series are that I'm looking for, and it's done an okay job, but notice I didn't specify one of the constraints that I look at this chart and I'm like, why on earth is 2021, 2022 way over on the left and 2017, 2018 on the right? Like when I read things, I typically expect it to go up in time to the right. Now, that may not make sense in all cases, but I need to go in and fill in the missing constraints. So this is a common pattern, is you'll have something that it produces and then you need to refine it through iterating on the product. You continue the conversation and iterate on it. So I give it an additional constraint now at this point to improve its visualization. I say flip the chart so it increases in time as it moves to the right, and now it goes and fixes the chart and flips it to move to the right. So whenever you have something that's not quite right, not quite what you want, don't get frustrated and throw it away and say it's a terrible tool. No, think about, how do I go and express my additional constraint to get the right visualization or to get the right table or to get the right analysis? Now, I'm now going to go and I'm going to do something different. I want to go and take the data, and I actually want to do a calculation on it to transform the data into a different format that will be easier for me to work with later. So I'm going to say create a table that shows the ratio of graduate to undergraduate students over time as a decimal, and create a table displaying the results. So I'm very explicitly taking some data in order to create some new data, because this ratio does not exist in an original data set. Now I'm going to do something else, and this can be important when you're working with data, is to be really explicit about the formula that I want used. So I'm saying graduate divided by undergraduate. It could have been the other way around. I'm wanting graduate divided by undergraduate, so I'm going to specify that in my request. So what I'm doing here is I'm saying I'm using a pattern, which is to basically give it information on how to create new data, basically to create a new data set that it can then go and work with. So now it's gone and created the new data, and I see it displayed here. And part of the thing that is going to be nice is now that I've reformatted this, it's going to be easier to ask for what I want next, which is I want a visualization that shows this ratio over time. So now I can just say visualize this data. Again, I'm letting it infer things from the conversation. I could be more specific, but the key is it's really easy for me now to describe what I want, right? Because I've done this intermediate step to pre-populate and pre-create that ratio and calculate it, now all I have to say is visualize this data, and it can go and do what it needs to do. Now, if I hadn't done that intermediate step, I would have had a more complex prompt to describe all this. I would have had to say, go and divide graduate by undergraduate to create a new ratio, and then visualize this ratio as a function of time or whatever. I'd have to do something more complex. Now, I could have done all that in one step, but often it's easier to work with if we do things step by step, and we do it maybe one step at a time in a conversation. Now, sometimes we'll just give it a huge list of things to do at once, but it can be helpful to think about reshaping the data through a series of transformations to get it into a format and to look at it and to verify that, that process being applied to the data, which I can do up here and I can see it and it's in the right format, and then to go and generate the visualization. So that's another sort of small thing that you would typically want to do. Have it do the transformation, look at it, and make sure it looks right before you proceed with the visualization, where it may be harder to tell that it's made a mistake. Now, what else can we do if we're going and looking at a document like this? Well, I'm going to say what other data is in the original data set that correlates with this growth in graduate population relative to undergraduate population. So we see in time that the percentage of students at Vanderbilt that are graduate students is going up. And so I'm saying what else in this data set correlates with that or could be something related to that. And it gives me all of these different pieces of information. But I noticed something, right? It's leaving out all these other things. In particular, when you're talking about graduate students, typically we're also talking about grants, research funding. Usually we would expect there would be some association or correlation between the number of graduate students and the amount of research funding coming into the university. And I don't see that listed here. Now, this just goes to show you it's not perfect. It's not going to always be able to know the answer to your question. Don't get lazy and think that it absolves you of the need to go and understand the data and to do work yourself and to think yourself. No, you need to keep thinking and you need to be able to follow up with it with the right questions. It's a tool to help you, not a tool to replace you in many cases. Now, sometimes if you have a really simple thing and all you're doing is just drawing this graphic over and over, well, maybe it will. But if you're really, your goal is to be the one who's thinking through the data set and what does it tell us and those types of things, it's a tool to help you, and you can't just assume that it's going to do everything for you. Now, I then tell it, hey, I realize it's forgotten something. What about grants and contracts? This is, something that I would expect correlated with graduate tuition, with number of graduate students. It goes and tries to process it. Now, notice one of the things it does, it's going to go and say, hey, it looks like there was a mistake trying to access grants and contracts. The error suggests that there's no column grants and contracts. So it's telling me, hey, you asked for something. I don't see it in the data. It does, this could, be the actual name is slightly different. Check the column names again. And it goes through and then it finds total grants and contracts. So it's named differently. And it's saying, do you want to proceed with this instead? So it's a good thing. It's nice. It's confirming with us. It's not exactly what I said. So if you say exact column names, you're going to be in better shape. But on the other hand, if you say things that are related, it may be able to go and find it. In this case, it was able to find that there is a related name, but not the exact one. And this is one of the powers of it, is to go and do those types of things. So it asked me if I'd like to proceed. I say yes with that modified column. It then goes and extracts the total grants and contracts over time. Now notice it's doing something else in here. It says the error suggests that total grants and contract contains $ characters which are preventing conversion to the integer data type. You're going to see it basically looking at the data, and if it encounters data that has formatting or other things that are problematic, it's going to try to fix them. You want to make sure that it does that correctly, that it does that data cleansing or reformatting correctly. And in this case down here, we can see that it is doing what I would expect. Now, it now tells us that it can check the correlation between this and students. Would I want to proceed? And again, this is a pattern. Over and over again, we're going to see it stopping at different points. Either to confirm that we want to continue, confirm that its analysis of like what the column name actually could be versus what I asked for is correct, or that it just hits some output limit. So we're going to say proceed. That's that interaction pattern. And now it's going to go and tell us the correlation. The amount of grant and contract funding is approximately 0.9. This is a strong positive correlation. Now I'm going to ask it to go and visualize the two metrics together, and now I see grants and contracts over time, graduate enrollment as a percentage of total students over time. So this is a really powerful technique. Going and working with structured data, you can really quickly do interesting visualizations and do all kinds of analysis on the data, ask questions about it. And it's going to be easier if the data set's smaller, but if you have big data sets that are really well structured, it also works well on them as well. particularly if we're looking at like summary statistics and things like that. If you start doing textual analysis, things get a little bit trickier, but if you have like numerical, well-structured data and you want to do a lot of different types of analysis on it, it can go and do those analyses for you. And it does a fantastic job at it.